Hi everyone, welcome to another tutorial. In this tutorial we're gonna make a game, kind of like the game you can see on Google Chrome browser when you don't have any internet. I'm gonna show it to you real quick. This is how the final game is gonna look like code-wise, and the game itself is gonna look like this. And you got a player that's gonna be running forward, well, appear to be running forward, and you're gonna be getting a score each time you jump over one of these like dangers, and of course if you hit one of them you're gonna get a game over, and that's pretty much the whole game. It's gonna have some really cool topics for us to work with, so let's get started. I'm gonna go back to projects, create a new project. We're gonna call these running game. Why not? You can call it whatever you want, of course. And so this is the initial screen for, I'm gonna make the code bigger. Check if it's recording correctly. Yes, it is. Awesome. Okay, so first of all, we're gonna need a character. So I'm gonna come here to sprites, new sprite. I'm gonna draw something fairly simple. I think it's a good opportunity as well to talk about like how can you create a bit more of a realistic kind of character. Not realistic, but at least like looking a bit more like pixel arty kind of. So what I do here is I take away the adjacent like 90-degree connections, if that make any sense. That makes any sense. Let's see, kind of like this. Take these out. Take these two out, this one out, this one out. This is something they do a lot when making characters, and it gives like a bit of a more professional kind of look. So it's kind of like a Sonic, if you think about it. And I'm gonna color it, fill. Let's do some green. I like green. Let's do this. Oh, too much. Maybe darker. Darker. I'm gonna do some eyes. Kind of like here and here, and maybe a bit larger. Now I'm gonna go with a bit of more light green. I'm gonna make here some kind of like lights shining from above, kind of like this. Fill this one here. Maybe a bit more dark, like in the middle. Maybe I could do like a second layer. So maybe like fill, kind of like this maybe. So you can see here in a more like small view how it's looking. I think that's good enough for me. The only thing I don't quite like is this like bump here. Let me erase that. I think that looks better. Okay, actually something I could do, pencil, eyedropping, grab this one, and maybe do a bit of a like bump here over like a cheek. And maybe grabbing the other one and maybe just a quick dot there. I think that looks nice. Yeah. Maybe just a bit more from this one here, but from this side. Yeah, loving it. Great. So we got this character. Actually, maybe just here. Like this. Yeah, great. Okay, I'm getting too much distraction from this, but it's also like really fun to make your characters and stuff. Great. So I got this character now, and I'm gonna change the name to, let's call it hero. Let's copy this line of code right here. Copy it. Let's go to code, and here in the draw function, I'm gonna create a new line, paste it, and you should be able to see your character on the screen. Check if that's being recorded. Yes, it is. Awesome. Great. So we got a character on the screen. We're gonna move it a bit to the left, -80, a bit downwards, minus 50. But since our character is going to be moving, I'm going to add something to these 50. I'm going to add something called hero underscore y, which is going to be a variable that's going to help us make our character jump. So we got that there, and let's initialize that variable. Let's say hero underscore y equals to 0. Now we're gonna have to think now, what are the conditions for a character to jump? And that's pretty simple. Like if I click the screen or I touch the screen, if it's a touching device, then I'm gonna say if touch.touching, and the second condition for this to be true, for the jumping to actually happen, is if my hero is actually on the ground. And we're going to use this double equal sign, that pretty much what they do, like in the previous tutorial, we saw that we could assign a variable, a value to a variable. We could assign a value to a variable. That's pretty much what I was trying to say. So I'm going to do an example here in the console. I'm going to write a equal 3, and that's what I'm doing. I'm assigning a number to a variable. But when I say equal, what I'm doing is checking if the value inside the variable is actually 3. If I get a 1, that means it's true. If I get, for example, if I say is a equal than 4, that's a 0. That's false, right? So that's why I got a 0. So I'm checking. That's why I use a double equal sign, because I'm checking. Great. So what's going to happen if touching and hero is actually on the screen? Sorry, in the floor. I'm going to use another variable called hero underscore vy. We're going to call that velocity in y, and we're going to say equal to 7. Okay, so I'm going to get like an upward velocity. Great. Now, in order for this velocity to affect the actual hero y, we're going to say hero underscore y. We're going to increase it. So we're going to say hero underscore y plus hero underscore by. So I'm increasing hero y by hero by. That's what I'm doing. If I reload the game, and if I touch the screen, it moves upwards. So two things are happening. First of all, my character is not coming back down. And second, the character is not like, well, the screen is not reloading. So I get like all these prints of the same character on the screen. So to repair the second one, we're going to say screen dot fill rect. We're going to draw a rectangle each time these draw loops, right? And we're going to say, you know, this rectangle is going to be at 0, 0, so in the center. We're going to say screen dot width as the width of the rectangle, and we're going to say screen dot height for the height. And the color, I'm going to use a, let's see. Well, you know, something that maybe I didn't talk about last tutorial is that you can pick some like basic color. For example, let's say blue, right? You're not going to be so, you won't be as specific. You couldn't be as specific as you would want to, but you can say RGB as the other way, with the other time we did it, 0, 0, 0, or whatever number you want, and then click Control or click here in this button while the cursor is over the word. That's really important to notice. And here you can be more specific with what color you want to pick. Okay. So there you go. I got a character. I got a nice blue sky. I'm gonna go with lighter actually. I like this one. Oh, look at that. My character just went over the rooftop. Okay, we repaired only one of those things, which means my character is still going upward into heavens. So let's, to correct that, we're gonna have to make gravity. And gravity means having always a downward pull. So we're gonna say, you know what, hero vy equal hero underscore by. Sorry, it's underscore by in both cases. I'm just like not saying the whole thing. Minus 0.3, and now my character is going downwards, but you cannot make it jump. So that's not good. But I mean, it's working. It's just not working as I would want. So how can I say, yes, go down, but until you reach the point of the floor, then you couldn't go more down than that, okay? So what we're gonna do is we're gonna use something called a max function. So the max function gets two parameters, two arguments actually. So the first argument is, let's say, a 2, one value and another value, let's say a 3. And it will always give you the highest value, right? So let's say 20 and 3, you get a 20, right? So here we're gonna say, you know what, give me the max value out of 0 or this addition. Okay, let's see how it goes. If I reload the game, I can jump and it stops at here, right here, right? So something I want to show you so you can better appreciate what's going on is you can click here in this little bug, you can see the variables, you can see hero VY is always going down, 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 down. And hero Y is 0. As soon as I click, hero VY is going to erase whatever, it's going to overwrite whatever you have here, and it's going to put a 7. And then the 7 is going to become, so hero Y is going to be the 0 you used to have plus 6.7, because you got the 7 minus the 0.3, 6.7. And then the next iteration, you're going to have, actually, you know what, let's just do it right now. So I'm going to do print hero underscore Y. If I reload the game and I jump, pause the game, here we're going to be able to see it was 0, then 6.7, 6.7 plus 6.4 in the next iteration, because the 6.7 decreased 0.3 again. We got this, then 6.1, then 5.8. It's being added. Then it reaches a point in which it is not adding anymore, because the number of hero VY, the value inside hero VY is being negative. So here is that turning point here. 76, 77, 77, 78, and then here it starts to go down. 77, 76, and so forth, until you reach again. So here is supposed to be probably going to subtract something bigger than 4.5. I don't think it's going to be 4.5. Because here from 11 to 4.5, it took away like 5 units, and here it's going to take more. But since 0 is bigger than whatever you would get, then that's why the 0 prevailed, right? So we got that working. That's awesome. My character now jumps, right? That's great. And if you want to take like a bit of a look of what's going on, like in the actual in real time to the variable, you can just like check that out. Great. Now we're gonna go to the second stage of our process. Sorry, I didn't tell you that, but there are like 4 stages. First stage, make our character appear and jump. Second stage, we're gonna make the floor move. You know, make the illusion of moving. For this part, I'm gonna give you the code, and we're gonna practice something which is copy and pasting and analyzing, so we can tweak for our own benefit. And that's something that is widely used among programmers. So we're gonna make that. I'm gonna give you the piece of code. And we're gonna put it in the comments below. Well, I mean in the description of the video. You can get it from there. But yeah, we're gonna do that. So give me just 1 second. Let me grab that piece of code. So they're always like in the remaining parts of the game. Sorry for the. I don't know if you can hear like the birds here. There's so many bird noises. Moving floor. Here it is. Okay. So there are several pieces of code. So the first one is here in the init function. We're gonna paste these. Position equals 0, speed equal 2. We're gonna talk a bit about it. Then we're gonna have this piece of code right here. this one right here. Oh my god, let me just, okay. And last but not least, this piece of code. And this is really interesting why it's happening. I mean, how this works. We'll do it here in the end. So, in some cases, where I paste the code matters. So just try to stick with it. Then, after you understand what's going on, maybe you're gonna get a sense of if it's really needed to be in that position, or it can be afterwards or below whatever piece of code I have. Great. So this is our code for our moving floor. Let's see if it works. It's not working because I don't have any floor drawn. My bad. Let me just check if the recording is going on. It is. That's awesome. Great. I once got an issue with that, so I just want to make sure it's working correctly now. I'm gonna show you how to draw some really cool brick floor. This is really interesting. Check this out. I'm gonna draw a new sprite, and I'm gonna use these tools called vertical symmetry and horizontal symmetry. I'm gonna turn both on, and I'm gonna pick really cool color. Let's go with a purple. Yeah, purple. Why not? I'm gonna draw some dark, really dark purple kind of line here. You're gonna get a sense of what I'm doing in a minute, or earlier. And I think I'm gonna go, no, that's not correct. I'm gonna turn off horizontal symmetry, and I'm gonna stay with the vertical symmetry. I'm gonna do this block right here, these blocks. I'm gonna do this one here, this one here. Great. I'm gonna do this one here, this one here. I think I messed it up because I should have filled with another color the whole thing before this, because now I have to click more times. Anyway, it's not that bad. I'm gonna grab this purple. Oh, fail. Great. Huh. I think the fill tool doesn't work with the symmetry. Like, it's not only with the pencil. Interesting. I like this one better. And I'm gonna do some lighting, kind of like this, but I don't want it to be mirrored because the light is only coming from one side, not from both sides. So that's, I'm gonna undo that. You can also undo with Command Z or Control Z, or this one right here, this button. I'm gonna take away this vertical symmetry, and now I'm gonna do it only in one brick though. I'm gonna show you a secret. Why, it's not that much of a secret, right? But anyway, like this. Yeah, looks nice. I like it. Maybe just a bit more vertical. Yeah, correct. And I'm gonna go with a darker color. Maybe darker. Kind of like this. Check that out. Yeah, why not? I'm gonna use the select tool. I'm gonna select just the inside of the block. I'm gonna copy, paste it. Oh no, what did I do? I cut it, sorry. So there's an easier way actually. Here it says if you click Alt and click, you clone it. So because I have a Mac keyboard, it's gonna be an option. Clone it, clone it, clone it, clone it, clone it. My bad. I'm gonna select this whole thing again. Clone it. Here you're gonna just stay with one part, and that's how it should be actually. Clone it. But if I bring it again, oh, it works. Okay, awesome. And look at that. Looks pretty good, right? Let's call it wall. Let's apply that. Let's go to code. Oh, there it is. Check that out. Ain't that pretty? Awesome. We got the wall working, and I really like the look of it. Let's just reload it to make it look like not so fast. Great. Now let's analyze what our code is doing. So Let me just have a sip of water. I'm talking too much. Great. So first of all, we got a position variable which starts at 0, and since we are not actually traveling in distance, we just want to keep track of it, right? If I were, because the character is not moving forward, it just looks it's moving forward, but actually like the floor is moving backwards, and not even just backwards. It's making the illusion of going only backwards, but it's actually moving back and forth. I'm gonna show you in a moment. But still, we are taking track of, we're keeping track of where we are supposedly, right? Like position 0, this is where we supposedly are in travel distance. As you can remember, these are comments. These are just meant for the programmer to read. These are like notes. These are not run by the computer. And they usually start with a double /, or if you want a multi-line comment, you use a / and an asterisk at the beginning and at the end. Kind of like this and this, right? Everything here inside is gonna be a comment. So something to keep account of. So speed's gonna be 2, and as you can see here in the update function, we're gonna have position equal position plus speed. So it's just a variable that is increasing by speed. So the first one's gonna be 0. The next one's gonna be 2. Let's just do a simple. I'm gonna reload. I'm gonna pause. Oh, that's not gonna be working. Yeah. Let's just print position. I just want you to see. And something really important to take notice of is that speed is increasing 0.001 each iteration. So the difficulty of the game is going to be increasing very little by very little, right? So it's like the speed of the character is going faster and faster and faster, right? So if I reload the game, check. Oh, sorry. Okay, here it is. So it starts with 2, 4, but not quite just the 4. It's a 0.001 more, should be, right? But I don't know why it's getting these decimals. But anyway, here you get a 0.002. I think it's gotta be like something with the memory. I once watched a video about this kind of thing, like why sometimes you get these numbers with computer based information. So yeah, this is supposed to be a 6, this is supposed to be, this is 9, is it? Anyway, it's increasing little by little. 12, 14, 16, 18, 20, 22, and so forth. And yeah, so position is increasing. That's what you get, and it's increasing not by the same number, but little by little it's increasing like faster, right? And yeah, that's pretty much what's going on. So just remember, we got a variable called position that is increasing, right? That is keeping track of where supposedly I am right now. My character is, of course. So, and then here, something really interesting is the loop that's making the floor appear. So as you can see, I have not one, but many of the bricks I drew, right? So how many actually? Well, it's hard to count, but what I can do is just make like a little something here, maybe like a little line, just to count those. And let's go back to code, and let's see how many, if I drag the screen, we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 blocks of bricks. And how am I supposed to do that with these 3 lines of code? Well, so here we have something called a for loop. And give me just 1 second. A for loop. That's where as I was saying, a for loop. And a for loop, pretty much what it does is a loop that repeats. And give me just 1 second. Sorry, there was a bit of a noise. Okay, great. So a for loop, what it does is repeat something an unspecified amount of times. So let's say, for example, a for loop starts with the word for, then you got a variable. So I is usually the name most programmers use for that variable. But you can count it, you can call it whatever you want. But I'm going to start at 0. I'm going to call it I. And I'm going to say for I to 6, let's say, to 5. What do I want to happen? Well, print hello, but it has to be under, yeah, in between double quotes. And as you can see, we got 1, 2, 3, 4, 5, 6 hellos. Awesome, right? Why 6 if I say it from 0 to 5? Well, because you got the 0, that counts as 1. The first one, sorry. Then 1, 2, 3, 4, 5, then you got 6, right? And what's happening with the I variable during that loop? Let's do it again. And instead of printing hello, I'm going to say I. Print whatever is inside the variable I. Interesting. So it prints a 0, prints a 1, prints a 2, prints a 3, prints a 4, prints a 5. And this 0 at the end is just like the end of the variable. So we can ignore that one. So it's getting 6 numbers from 0 to 5. Hope that makes sense. Here, as you can see, we're doing a for loop. Or this by 1 is just like something else you can do to a for loop. And you can say like, go by 1 by 1. And you should be thinking right now like, well, I didn't set it before and it was 1 by 1. Yeah, the default is by 1. So you can say by 2, for example. And if I print it, it's going to go 0, 2, 4. And the 5 is not going to be there because from 4 is going to be, next one is going to be 6. And you got to stop at 5. So that's why. So you can change that. Actually, here you can delete this part. It's not going to be, it's not making anything change. So could be without this. And what the loop is going to be doing 6 times? Well, it's going to draw a sprite. Which sprite? The wall. And then here, okay, so I remember I is changing. It's changing all the way from -6 to 6. Interesting. So the first time it loops is going to be a -6 times 40. What's that? That's -240. Okay, minus position, and then we got this weird thing. So let's just ignore this for a minute. I'm going to explain it in a moment. But we're going to come back to it. Here we got a -86, which is where it's supposed to be located in the y-axis, okay? And this is the size of it. Okay, interesting. But what is this doing? Well, remember the I is multiplying by 40? Yes. So the first block, let's just ignore this part for a moment, okay? Let's just ignore the minus position. This is called a modulo operator. Position modulo 40. Let's ignore that. So what's happening is that I times 40 is creating a space for each one. That's really like elegant solution because -6, which is the first iteration, times 40, you get a -240. So that means our first block is going to be located, let's see, at -240. Kind of like here. Kind of like here. Actually, it's kind of moving a bit because of the next part of the code, but yeah, you get the point. The second one, actually, if I just reload the game and I pause it really quickly. Oh, it moved. Let me just, kind of like here. No, didn't quite get it. Anyway, you get my point. And then the next iteration is going to be a -5 times 40. That's going to be a -200, kind of like here. You can see it's kind of there, but it's moving a bit. I couldn't quite pause it like exactly in the moment. And then the next one is going to be a -4 times 40. That's -60. It's going to be here. And you can see like each block is being located depending on the value of I, right? So I times 40 gives a position. Actually, if I just take this out, I'm going to delete it for a moment. And I just play the game. There you can see, if I put the cursor here, that's going to be really precise now. There you go. minus 240, 200, 160, 120, 80, 40. When I is 0, 0 times 40 is 0. So you get the point, right? So that's how each block is being located. 13 blocks, each block apart from each other by 40 pixels, which is great because our blocks are 40 pixels wide. If I just say that my blocks are going to be 30 pixel wide and high, this would be what happened. So it's working really good. But how can I make it move, make the illusion of moving? With this part of the code. And as you can see, I'm going to reload it. It's going back and forth, and it's making the illusion, because it's seamless, that is moving forward and backward, right? I mean, that is moving only, my character is moving forward. So how is that working? Well, this operator called the modulo operator is really simple. What it does is giving you the remainder of whatever division you set out. So you say 2 modulo 40, how many times can you fit the 40 inside the 2? Well, 0. And what's the remainder? A 2. Okay. How about a 42 modulo 40? Well, how many times can you fit the 40 in 42? 1. But I don't care about that 1. I'm caring about the remainder. You get a 2 again. So because I'm doing position modulo 40, you're always getting like a reset on the numbers. You're going to be like 2, 4, blah, 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 and then again like a 2, but a bigger 2, because remember, speed is increasing. So you can take a moment to analyze it. I took a moment doing it by paper. Well, not by paper, but you know, like, well, yeah, it actually was by paper. Like trying to figure what's going on in a more detail. But if it works for you just to know what's going on, let's say 84. If you figure out correctly, you're gonna get a 4. It's the remainder. You can fit 2 times the 40 in the 84, and you get a 4 as a remainder. So, cool stuff, right? Great. So that's how it's working pretty much. I'm gonna take this line of code. You can print this. This is really interesting if you want to like see what's going on in a more of a detail level. You can see the block number -6 gets a minus. This is the position of the center, and then 244 is moving backward, and then 246 is moving backward, and then it gets to a point in which it resets. So that point 240. So for example, here before these 240, I used to have a -278, right? And then it reloaded back to -240, but just a bit more now. I used to have a 240, well, 242. So let me just get to the 262, 240, here it is. And then here, it reloads to 242, but a bit more to the side. So that's making the illusion of the blocks moving, which is pretty interesting. I'm gonna comment this out again. Great, second stage completed. Let's see how much time are we in the tutorial. Okay, half an hour, that's good. Now we're gonna move to the next part of the code, which is making the blades. And the first part, you guessed correctly probably, is drawing the blades. So I'm gonna go to make a new sprite. I'm gonna rename that to blade. Oh, I don't like this size. Why is that? New sprite. Huh, that's interesting. Everyone is 32 by 32, and I get that change. That's weird. Okay, 32 by 32. No big deal. Great. Now I'm gonna go with a regular kind of blade. Maybe red. Danger. I'm gonna go with a darker. No, maybe one side is gonna be because the light comes from the left. I'm gonna make one line brighter than the other. And actually, I think I messed it up. Let's see if I can select this. And I can copy and then horizontal flip. No, it's not. Oh, because I have to copy and paste it. Duh. Paste? Yeah. Horizontal flip? Yeah. Awesome. And I'm gonna have to change the color. Ah, not the whole thing. Well, anyway. Ah, no. Yep. No. Okay. Pencil, eyedropper. There you go. And the inside is gonna be like here in the middle, maybe. Film. And I'm gonna do quite some lines now. Maybe a really light one. I'm gonna fill that in. Yep. Well, not my best drawing, but works. I try to remember like how blades used like look. Usually I take like I watch in Google Images just like how does a spike or a metallic blade looks like. Yeah, why not? And then maybe a not so bright, but cool anyway. Kinda. And it's hard to make diagonals here. But anyway, just remember whatever you see, it's gonna look cooler when it's small, sometimes. Not so sure now. Yeah, why not? I'm not gonna get that picky now. Okay, so now for the code for this blade, I'm gonna 2 lines of code for the init function. I'll try to make this tutorial a bit quicker, not so long lasting. And here we're gonna have a big for loop in the update function. I'm gonna put it here, and then I'm gonna have another for loop for the drawing of the blades in the draw function. Here we go. If I reload the game, should be able to not see anything because the name of my blade is Blade, right? Oh, I didn't change the name. Look at that. Blade. There you go. So nothing's happening. I mean, I'm not dying if I touch the blade, but still, they come at a random position after the second, after the first 3 blades appear. They look quite nice, I'm not gonna lie. Oh, that would have killed me. Okay, so let's see what's going on before we get to the end of the game. We are using something called lists here in order for our blades to appear. And a list, what's a list? A list is something that programmers like to call data structure. And data structure, pretty much what it is just a structure to store data, right? So let's say, for example, a shopping list. A shopping list is a data structure because I'm storing data in a post-it note and I'm storing several values, right? Because let's say, what would you do if you didn't have like lists in the world? You would be like, you know what? Shop item 1 equals, let's say, apples. Okay, 1 variable. And you know, but I am also gonna shop for some eggs. So if I store it in the same variable, I'm gonna overwrite the other value I used to have. So I have to make another variable. What a bummer. Oh, but I also got to buy some milk. So shop item 3, milk. Oh, look at that. I got 3 variables now because I'm going to shop like groceries. That's not practical. How about I do something called shopping list. That's a big name. Let's do it shorter. Shop list equals, and I use these square brackets, and I store apples, comma, milk, comma, X. Oh, interesting. But how can I access each one of them? Well, you can use the index, for example, and I can say shop list in between the square brackets 0. Let's say 1. I get the milk. I thought I would get the first one. So instead of 1, you use 0 for lists to get the first item, right? So that's usually how it goes. Sorry. And if I put a 2, you guessed right, you get X, which is the third item. If I put a 3, probably that's something that came into your mind, you get 0. There's nothing in there. That's like outside of my list. So yeah, that's how lists work. You can push items in, you can take items out. There are several methods to lists, several actions you can do. For that, you can go to documentation, microscript programming, go to list operations, and here are like different properties and actions that you can do with a list. For example, list.length will give you back the length of the list, or in other words, the number of elements in the list. Push, you can push an element to the list. It's gonna end up at the end of the list. Insert is gonna insert it at the front, and you can see like what each one of them does. Sorry. Each one of them does. Yes, correct. Great. So here we're creating a list with 3 values, and these are the blade's original position. Original positioning what? I mean, nothing is moving but the floor. Yeah, but remember we're keeping track of the position of my character. So these are the position based on that, right? And here we're keeping track of the blades that have already passed. And here we have like not passed, not passed, not passed. We're using a 0-1 kind of system for if it has passed or not passed, right? Great. Then we added this big piece of code, which is a big for loop. I'm gonna go not in that much of a detail with it, but pretty much it's going a for loop starting at 0 all the way to blade's length. I just talked about blade's length. What's that? That is how many elements are in here. But why would you want to decrease it by 1? Well, because I want to go 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. Because those are the indexes, the 0, the 1, and the 2. But my blades.length is going to give me a 3 because there are 3 elements. So I want to go all the way from 0 to 3 minus 1, which is 2. And this is looping in for each of these, looping through each of these blade positions. So here I just made this line of code in order to like see what's going on, to see like where each blade was at the beginning. And it says here, you know what, if the position of the blade is lower than position minus 120, so pretty much what we're saying is if the position already passed the player, then reset it to it has not yet passed and to an actual right random position, right? So that's what's going on. We're doing, if this is true, if I already passed the player, then blade, whatever I'm on, it could be the 0, it could be the 1, it could be the 2, then assign to that one, let's say it was the first one, it was the one, it was 200, right? Assign position plus 280 plus random.next times 200. So this is just making a new position in the x-axis for the blade, right? And then it say that it has not yet passed again. And so that's this conditional what's doing. And next up, we got these other conditional. And as you can probably remember from last tutorial, we got this abs function that is giving me the absolute value between this subtraction. So it's the position minus the position of the blade. And if it's lower than 10, it means that I'm close to the blade horizontally, right? And then if that's true, then I'm checking if I'm too close vertically by checking the hero underscore y. If that is too low, which means I'm not that high in the air, then it means I'm too close vertically to the blade. And that means running is over. So stop running the game. This is a variable we haven't started yet. We're going to do in the next stage. But we're saying, you know what? Stop running the game. Game over equals to true. So the game is going to be over, right? Else if not, then I do pass the blade and give me one score, right? That's what this is doing. I'll have a bit of a uncompleted comment here, sorry. You can delete that as well if you have it. I'm gonna try to paste the correct one there. Okay, great, so this is what's going on. And in here we have a simple loop that goes through each one of the blades, right? And draw each blade minus position minus 80 to make it appear where it's supposed to be. Yeah, so if I reload the game, I have a really precise Y position here, but I mean it works, so that's great. I don't think I need the decimal numbers though, that's too much. Take that out. Yeah, that's just fine. Great, so that's working. Now let's go to the final stage, which is making the core functionality of the game, which means when's the game gonna be over, and actually make it go that way. So I'm gonna go here at the end of this line of the init function, and I'm gonna add these 3 lines of code, which pretty much are saying if game over, sorry, no, it's not saying if, it's just saying game over is false at the beginning of the game, running is false because I'm gonna have a ready screen, so it's not running, and score equals to 0 because, you know, I'm just starting with the game. And then in the update function, I'm gonna put some code into at the beginning and at the end. So let's just remember, we always have to work inside this update function and at the end of this. And if you put a cursor over the word end, you're gonna see which word highlights, and that means to which function or loop or conditional this word end relates to. So here I'm gonna hit enter, and before I paste my code, I'm gonna select all of these. I'm gonna click tab to indent it. It's not mandatory, but it makes your code look nicer and be more readable. At least for me it is. So if game over, then game over plus equal 1, which remember, this is precisely the same as saying game over equals game over plus 1. But it's a shorter way of saying it, and that's something you may want to practice as well. This is called an augmented operator. And if you reach 300, or I mean over 300, which is pretty much like 5 seconds, then init, you're running again the init function, right? Else if running, so if running is true, which in the first iteration is not gonna be, unless you click really fast your mouse. Yeah, it could be, I mean, it could be. No, actually, I don't think it's, no, the first iteration couldn't be. Anyway, I'm gonna continue. Else if, so we're gonna add an else. So remember here we have a big conditional, if, else if. Else if, I don't know if we have talked about it, but it's pretty much like saying else if, right? It's like another, so if this is not true, this will run. If this is true, this is not running. because that's why it's an else if. And here I'm gonna paste this part of the code. So we got an if, else if, and then an else. Those are parts of the same conditional. All the other conditionals are inside this else if. Anyway, inside this else, I got an if conditional saying if I am touching the screen. So if it is not game over and it is not running the game, then if touching the screen, then running equals to true and the game will start, right? And last but definitely not least, we are going to put everything related to like the words on the screen. And that means going at the end of this draw function, but inside this word end, this end word. And here we have a screen draw text. So we're drawing the score, 120 to the right, 80 upward, 20 in font. And this way of writing a color is called hexadecimal. And if I click Control, it's gonna work the same way. I mean, you can keep it white. You can click Control, and if you click Control and you change it, it's gonna change to RGB. So it's just another way of writing color. If you go to websites in which you can grab like color palettes and stuff, you're gonna see they can give it to you that color in many ways, right? Like RGB, hexadecimal, and some others. But yeah, this is all white, so you might want to change it if you want. And so if game over, so the score is always gonna be there. Remember, the score is increasing every time you pass one of those blades. But if game is over, then fill the screen with in the center, big as the screen, wide as the screen, tall as the screen, and you got the RGBA. That's something I never used, the A. Actually, I think it works without the A as well. But A stands for alpha, which means you get a fourth value, which is the alpha value, which means how transparent is it. But I never knew there was an A there. I mean, you could do it, and you couldn't if you don't want to. That's fine. Then draw great game over. The order here matters. So first we got the red rectangle, and then you get the game over. If we were to do it otherwise, we would get this like reddish taint on our game over words, right? Else if game over, then do that. But if it's not game over, check this out. Check if not running, then so if it's not game over and it's not running, then what you should be showing is the word ready on the screen. At the center, 30 high, 50 font, and white. And that's pretty much how our game works now. If you play the whole thing, you're gonna be able to see, okay, you don't want that big of a screen. You're gonna be taking care of those blades there. And now, since you quite understand everything in the code, you can tweak it for your own purposes. So have fun with this game, and I'll see you in our next tutorial. Thank you for watching.